Now, most people probably wouldn't recognize something like this, but if you work in IT or you're used to configuring computers, for instance, you'll know that it's an IP address. Now, of course, it's just not practical to remember every single IP address that's out there, so you don't normally connect to a computer using its IP address. Instead, you use something like this, a fully qualified domain name, and show that to a user, and then they know what you're talking about. That's the sort of thing that we type into a web browser. That's what you put into an application. Otherwise, the maintenance would be a nightmare. But how on earth do you convert a fully qualified domain name into an IP address? Well, for that you need a DNS server. And if you want to know how to build your own DNS server, check out this video, because that's exactly what we'll be doing. Now, before I actually get started with building this DNS server, it would help if I explained the plan. There's going to be quite a lot to do. I'm going to break it up into sections. I'll give you a timeline. If you want to skip ahead, feel free. Look at other sections as you see fit. But I need to set out the plan, the agenda, to explain what it is I'm doing and why I'm doing it. So if we look at this diagram here, we've got a very basic diagram. Not a great deal going on as yet, but I need to be able to resolve my own internal host names, basically. I can't rely on a DNS server out here, for instance, to know a web server that I've connected into this network. It just ain't going to happen, basically. So for that reason, I need a DNS server. It's a lot better than going around every single machine and updating every single machine's host file. So that's the first thing we need to do, is to build a virtual machine. We'll then install Ubuntu onto it. Then we'll install the Bind service. And then we'll configure that with a series of host names so that if anybody comes along and queries this server, they'll be able to resolve internal FQDNs to the internal IP addresses that we're using. And I mean, granted, we don't have many computers now, but over time it might build up. But there's also another reason that if you want to connect to a computer, say like a web browser, if you connect to it through its IP address, well, yeah, you're going to always get that web browser warning about the self-signed certificate, it's not trusted, and so on. And to get around that, you need fully qualified domain names. So that's an extra incentive, if you will. So yeah, that's the first step, build our own internal DNS server, and that solves a big problem for us. So the idea is we'll have a DHCP server, it'll be configured, and it'll just tell any computer that gets an IP address, come and talk to this server. Servers like this one and this one that have private IPs, we'll actually configure that DNS server on there manually, but everybody else will just get controlled through DHCP. Now, we can also take advantage of caching on this DNS server, because what normally happens is if I've got a computer like this one, for example, if it wants to connect to a computer that's on the public internet, it would normally go out to what's called a root server. That would eventually work out where this server learns of a DNS server that it can talk to resolve a particular fully qualified domain name, and then eventually it gets its IP address. So it's a pretty slow process. I mean, it's not not slow for like say you or I, but it's slow for a computer. But we can take advantage of caching, where what we can do is we can actually get this server to do all that grunt work for us. So the idea is this computer would talk to this server. This server would then go out and find out what that public IP address is, and it would cache it. And then any computer on our network that also wants to get that IP address, it'll get it pretty much straight away because this computer's already cached it. So it saves quite a bit of time basically when it comes to DNS resolution. Now, there's also another feature we can take advantage of, in that, well, there are various services being made available to kind of add an extra level of security, if you will, to DNS, because we hear about DNS hijacking and all sorts, but one in particular I'm interested in is one by Cloudflare, for example, where they'll protect you to a certain degree from malware. So their basic tier 1 level, if you will, what that does, it acts as like a DNS forwarder for you. If we point our server here to Cloudflare's DNS servers, it saves us a bit of time in the DNS process, because this won't go out and talk to the actual root service, for example. It'll just go to Cloudflare. Cloudflare's servers will cache that, so this one will get a quicker response anyway. But if we step up to what I would consider to be tier 2, we'll get a bit of malware protection. And the idea is let's say this computer here decides it wants to talk to a specific public DNS, public web server, for example. Say we've clicked on a link or something. This computer is going to talk to this computer. This computer will talk to, Cloudflare's server. And then Cloudflare's server will provide a bit of protection for malware. So if it knows that this particular website that we're trying to connect to has got malware on it, it won't actually return that server's IP address, and our computer just can't connect to it. Until it's got an IP address, it can't connect to it. So it offers us like an extra layer of security. The other benefit of getting this server to act as what's going to be called a DNS forwarder is that it saves a bit on the management of the actual network as well. All we need to do is point all of our computers to that one server, and then we can decide what our DNS forwarders are going to be. If we decide to change to different DNS servers on the internet to do our work, it's a case of we just need to update this server plus the firewall rules, and that's it. We don't have to update DHCP. We don't have to go around every server that's got a static IP address, for example, pointing to that DNS server, or some public DNS server out here. It saves us a lot of time and manageability. So yeah, there's a few things to do. So first thing we need to do is to actually build a virtual machine. So what we're going to do now is to actually create the virtual machine itself. So, feel free to skip ahead if you've already got a computer running Ubuntu, or you've already got a virtual machine or a physical machine to install it on. But in my case, I've got to start from scratch. So I'm using ESXi. I'm going to click on that virtual machine section up there. Then we click on create register a virtual machine. What I've done is I've downloaded an ISO file. So it's just the actual installation files that we've got. We don't have an existing virtual machine to register or unpack or anything. So we go with the default option, which is to create a new virtual machine. We then give it a name. So in my case, this is called NS1. It's only relevant to ESXi itself. This is not going to get passed on to the operating system, for example, but it helps to keep them in sync. For the compatibility, I'm leaving it on version 7 because that's the version of hypervisor we're running. It's a case if I don't have any other hypervisors in the network, so yeah, I'll just leave it on the default. For the OS family, we want Linux, and for the guest OS, pretty straightforward. It's Ubuntu, and it's the 64-bit version of Ubuntu. So we then need to tell it where to actually store the files for this virtual machine, and then it's a case of, because we've told it which operating system we're installing, it's gone to a template, and this is what it's decided the computer needs to look like. So I'm going to make a bit of a change. I'm going to give this a bit more memory here. We're going to give it 2 gig. For the hard drive, I'm going to thin provision it because it's a lab, so I can do that. We'll just change the controller over to SAS a bit faster, although again it's a DNS server, to be honest, it doesn't really matter that much. For the network adapter, I only need the one, so I'm going to put that into the infrastructure network. And then what we need to do is we need to point this virtual machine at an ISO file, because that's what we've downloaded. So we're going to install Ubuntu 20.04-2 because that's the latest version as of this recording. So it's a case of click next. This is a summary of what we're doing. So just quick check. Yep, it's going into the infrastructure network. 2 gig of RAM. Thin provisioning. It's pointing at an ISO file. Right. So again, I mean, it's just like a DNS server, so it's not as if it does much, to be honest. So it's now created that virtual machine. But what I'm going to do is, just based on past experience, I'm going to make some slight changes. Because it's got this annoying habit of every now and again where it doesn't actually boot from the CD. So I'm going to make sure that's connected, and then it's set to connected power on. Click on save, and then we power it on. And click on the actual console. So I'm just using the actual basic console here that we've got getting access to through the actual the web browser, if you will, the web server that's running on ESXi. So it's just checking to make sure that there's no problems, and then it's just going to go through this whole process where basically there's there's a series of questions that it needs to get asked, and it's, I'm just checking there, it was just complaining of various problems there. Okay, so it's I got the impression where it said it failed to unmount the CD-ROM drive, so it's just going to basically go through this process where it's going to ask us a series of questions. We've got to answer those, and then eventually it'll install the operating system, and we'll be at the point where we can then install the actual bind service. So I'm just going to leave this running for a while, and then once we're ready to make a bit more progress, I'll bring you back. Right then, so that took a bit longer than, say, version 18 of Ubuntu, but in any case, we're now at the point where it's asking us what language we want to use. So I'm going to be a bit picky here, and I'm going to go for English UK. I do need to change the keyboard over to a UK keyboard as well, otherwise I'll have problems with some of the symbols, for example. So that goes and makes a bit of a change there, and now it's trying to obtain an IP address through DHCP. So I need to change this. I need to change this over to a manual IP address. So tell it we want a manual IP, then it wants the subnet. Now, the good thing is it's quite helpful. It'll tell you, if there's fields that definitely need filling in, gives you examples as well, which is quite useful. So if I jump out of that field there, it actually tells you, the format, for example, that you need to put there. So this one will be 172.16.17.0, and it's a /24 subnet. So this way I don't actually, I suppose with some operating systems they just ask for the subnet mask, which each to their own, I suppose. And its IP address will be 172.16.17.10. It's a pity actually it didn't sort of glean from that, what sort of information we should be putting in and automatically replicate the first 3 octets down there, for instance, but that would have been handy. Same with the gateway as well. I mean, kind of common sense should be telling it. Well, yeah, computers don't have common sense. I think more from the perspective of the developer. It would save you quite a bit of typing if they'd done that, but never mind. Now, for the DNS server, now, at the end of the process, this computer actually needs to point to itself as a DNS server, but I need to get it pointing to the internet before I can even get started with anything. So I'm going to point it over to a server that's with Cloudflare there. So that's 1002. So this is a one that provides like a tier 2 malware protection, if you will. And then the next thing I'm going to do is to put in the actual search domain here. Now, what this is basically, it's a bit of a time saver, if you will. If I, or either me or an application only uses an actual host name, when it's doing lookups, the computer's going to tag that search domain on the end. So if I, put in a query to say, what's the IP address of DHCP1, it'll automatically tag on that domain suffix there, and it'll actually do a DNS query for dhcp1.templab.lan. So that's the reason you put that in there. So we'll save that. So that's got itself a static IP. So that's that done. It's a virtual machine. There's only one interface, so it doesn't really matter. So I don't need to bond interfaces together. So that's that bit done. I don't have a proxy on this network. I mean, in a real live production network, you would definitely want to use a proxy for, production purposes, for being able to do your caching, for being able to do better security and so on. But this is a temporary lab, and yeah, I just don't have a proxy, so we'll leave that blank. I'll leave that as is for now. It's a case of that's what it wants to know where the archive mirror is. So yeah, I'll just leave it on the blank. On the default rather. It then wants to know what you want to do for carving up the hard drive. I'm just going to leave it on the defaults, to be honest. I'm not too fussed. So just go to done. So it gives us a bit of information. This is going to break, the actual hard drive up into partitions. That's what it's going to look like. So yeah, that's fine. Again, it's just a DNS server. It doesn't need to be anything special. It's a virtual machine. It ain't going to make no difference to me. So go to done. It's given a warning there about having it, breaking up into partitions and so on. You're going to lose all your data. Yeah, again, it's just a brand new machine, so I'm not fussed. So we'll go with that. And then off it goes. So what it wants to know now is, it wants a user account, and it wants a name for the computer. So in my case, I'm just going to use my own name, if I can spell it, basically. Because, I mean, basically, you don't want to be connecting into these computers as the root. That's just like ancient process that you don't connect in as root anymore. You want to use something like sudo. So a server's name, it's going to be called NS1. Interesting if it didn't mirror your name down to username, but never mind. Right, so password, it's going to be this. Should really be longer, but it's just a temporary one for the video. So, go done. Now, it's given me options here where it's saying, do you want to install OpenSSH? Now, I actually do. I'm just going to leave that as is, but the reason I want to do that is because it'll be easier for me to then configure it later on down the line. Once this is all up and running, I can then manage it through another computer. So yeah, we do want to install OpenSSH. Yeah, I'm not bothered about SSH keys at this stage. And there's a big long laundry list of things to install, which no, I'm not going to install those. These are things we can install afterwards. My goal is really just to get a basic operating system up and running, and then we'll install the extras on afterwards. So go with that. And then off it goes. It's just going to start, carving up the partition, installing all the files, and yeah, once it's ready for the next process, I'll bring you back. Right then, so the installation's finally done. Although I must admit, it's looking a bit deceptive to me because you've got this little animation keep going where it's saying, running the curtain hook. And it's like, well, is it still doing something? But then you look at the top and it's saying install complete. So the options are basically reboot now. So tell it to reboot. Yeah, failed to unmount the CD. Okay, so I need to disconnect the CD now. Out of curiosity, because the other version of Ubuntu I was running, yeah, that came installed with VMware's tools, whereas this one doesn't. So it's a case of I can't sort of disconnect the CD there and then. So what I'm going to do is I'm just going to turn it off. Let's close that down. I'm going to change the settings, and I'm going to point this basically back to the host drive as opposed to the ISO file. I mean, it said it was disconnected anyway, which is fine, but it's just like an extra bit of caution, really. So we'll now boot this back up. So it should then boot up, and then we should end up being left at the actual login prompt. So off that goes, and assuming I don't have any hiccups, what I'm going to do is I'm actually then going to just jump over to the management computer that I've got, because that should have SSH access into this computer. So I'll leave this to boot up. There you go. So that's now ready. Well, it's still up to something anyway. So I'm just going to wait for this to finish, and then what I'll do is I'll just get my management computer up and running, and then we'll log in through that. Okay, so the server's now up and running. So it's a case of I've come over to this management PC to get remote access into the server, because by having this terminal window running in the operating system, I can actually do copying and pasting. So it's going to make life a bit easier, basically. So first thing I need to do is to get access to that computer. So I put my user account there. So it's going to be 172.16.17.10. So we'll accept that fingerprint. And now wants to know what our password is. Right, so there you go. We're now logged in. Now, interesting enough, it's actually telling us there are some updates already available. So just to save a bit of time, I'm going to do the whole lot in one go. So I'm going to do an update first. Then I want to do an upgrade. So that way it'll update itself, and then it'll upgrade itself. So yeah, that looks right. Because one thing I did notice was while it was, mistyped it. I missed the app bit out. One thing I did notice while it was doing the actual install it was actually going out to the internet to do all this, checking for like security updates and so on. So this is probably going to take a while. So I'm just going to pause it there, and then once the actual server's up to date, I'll bring you back. So we've now installed Ubuntu onto a virtual machine. We've upgraded the operating system and it's running OpenSSH. So what we've done is to actually log into the computer now remotely, so that way I can do copying and pasting within this virtual machine. I can't copy and paste into the virtual machine, unfortunately, but I can at least do it within the machine, so it saves me a bit of hassle when it comes to like copying files and so on and backing them up. So first thing I need to do is to actually install the DNS Bind service, basically. So for that, it'll be sudo apt install, and then it's all the actual components, if you will. I'll just put -y in there so it just saves me any prompts later on. So we want the Bind service, we want the Bind utilities, documents, so bind 9-doc, DNS utils, so bind 9 utilities, bind 9 docs, and DNS. Okay, so what's the password? And then off it goes, and it'll just basically go out to the internet, out to those repositories, and pull all those files down, and then it'll actually install all of those parts. It's not actually operational, it's not up and running, and it's not actually configured at all. So that's the next thing we need to do, is to actually start configuring this. Well, now that we've got the Bind service installed, we need to start configuring it, because it's not actually doing what we want it to do, and the service isn't even running. So that's the first thing we need to do, is start making changes. So I'm switching over to the folder where the actual files are installed. It's the /etc/bind folder. Then we'll have a look at the actual content. So there's a bunch of files in there. The one I want to start off with is this one here, which is called named.conf.options. And what that is, it's what we're going to configure for the DNS forwarding. So the first thing I'm actually going to do, though, is I'm going to make a copy of this file. So just say copy that, paste that again, and then I'll just give it an extra extension, so we've got a copy of it for backup purposes. So that's basically the raw file. So we'll do another ls. So yeah, okay, so that's there. So the next thing I want to do is actually edit that file. Now, I mean, use whatever, text editor that you want, but it's going to, actually, I should be able to just paste that. So we want to edit this file and change it to be a forwarder. Now, if you look down here, it does mention how it's set up, and it's actually commented out that it's, it has the potential to be a forwarder, but all that has been commented out, and it tells you up here, it's a bit of description about what you need to do. But I want to be a bit more controlling, shall we say. I want to put some extra requirements in here, and I want to control what computers can actually make use of this service. So there's different ways you can go about it, but one way is to create an access list and then reference that. It makes life a bit easier, as you'll see. So the first thing I want to do is I'm going to create this access list at the top. We're going to call it Trusted Clients. Now, this is basically going to hold a list of, well, mostly subnets of all the computers that will be able to actually take advantage of this DNS server as a forwarder. So what I want to do is I'm going to put in a few entries here, and then I'll explain what they actually are. Some of them you'll recognize because they're subnets. So 172.16.18.0/24, 172.16.19.0/24. And we finish that off. So this is an access list that we're going to be using, and it's a case of this first entry here, which is called localhost, is just basically the local computer itself, the actual server. Localnets is the subnet that this computer is running on, and then we've got two other subnets, which are the other networks that we've got on our network, or at least our lab network, I should say. Now, normally what happens if you don't really do anything, there's not a great deal of control going on. The way they tend to behave is with those first two options there, where the actual computer itself can do these DNS lookups. Anything on the local network can do DNS lookups, but these other two subnets wouldn't. So that's why I've added these two extra in, because I've got a subnet, which is the management one, this one here, .18, and then .19 is the sort of like the lab network that we're going to be building. And I want to be able to give all the computers, access to this DNS server, because the way it's going to be set up is no one's got access to any like public DNS server, so they've got to have access to this one server. So I need to put in some extra options here. So there's one entry here. I've got to enable recursion. We need to put in a bit of a restriction here, which is, well, I'll call this first one. This one's going to be, I think it's allow query. So this is to allow an actual client to do a query. I'm going to reference that ACL at the top, because that's to allow just DNS queries basically. Then there's cached queries. If I could spell it properly. And that's going to be trusted clients as well. I've realised I've missed a bit on the one up there, so that's not going to work without that. And then there's allow recursion. So these are just basically controls over what computers can do. The DNS server does multiple sort of things, so that's why I've got 3 entries here. But it's a case of I'm setting restrictions that reference that access list at the top. I mean, I could actually put the individual subnets and entries that are in that ACL within these like curly brackets here. But this is an easier way of doing it, because it means if I want to add new networks later on down the line, I just need to update the actual access list itself. So I'm just double checking against my notes just to make sure I haven't missed anything there. So yes, we've enabled recursion. Yes, we've done that. Right. The next thing I want to do is I want to change this entry for the forwarders. So this is where we actually define what we're going to forward to, because we don't want to be going to root servers. We want control over what servers this computer is going to be using. It speeds up the caching and so on, but it also allows us to take advantage of Cloudflare, for example. So 1.1.1.2, and then it's 1.0.0.2. Some strange reason I keep thinking it's 2.0.0.2, but it's not. It's 1.0.0.2. So that's the list of forwarders that we want. So just double checking that. Then if we go back down here it's actually saying it's listening for IP version 6, and it's listening on any interface. Now, I don't really want to use IPv6, but for now what I'm going to do is I'm just going to be a bit more specific in terms of the port it can listen on. And for now, I'm going to restrict it to just its loopback address. So it can listen to itself. If I decide to add IPv6 later on, I can actually test IPv6 on this one and then expand it out. Because this one I don't know of like any subnets that we're going to use. There's no point putting any in. Now, another thing I want to do is the same for IP version 4. And for that one, I'll put in the same loopback, except the IP version 4 equivalent. And then its own IP address, which is 172.16.17.10. So basically what I'm doing is I'm just being a bit more restrictive in terms of what this computer is going to be listening to. Listening what interface it's going to be listening on for DNS requests, because it's a case of I've got to listen on the loopback address, so that's so that the computer itself can talk to its own DNS service. And I want computers that are on the 172.16.17 network, or at least any computer that references this IP address as a DNS server. I want them, I want this computer here, I want it listening on that specific IP address. Because if you're out, building like a production network out in the real world, you'll probably have like a management interface as well, and you don't really want to be listening to DNS requests on the management interface. That should be for management purposes only. Now, in our case, we've only got one interface. It's only a lab, but I just want to go along with that sort of like best practice. So just going to double check we've covered things. So we've got an access list. So there's the local host, local nets, and then our two subnets. Then down here we've got recursion, which is set to yes. Allow query, and that's pinned to the trusted clients ACL. Allow query cache. Make sure I've spelled that properly. That's pinned to trusted clients, and then allow recursion, and that's pinned to trusted clients. Then the forwarders, the two forwarders that I want to use for Cloudflare. And then down here, we're just restricting the port and the IP addresses that we're listening to, or listening on, I should say. Now, there is one thing I'm going to change, and that's this setting here, which is for the DNSSEC validation, or DNSSEC validation. In here, I'm actually going to set it to no. The reason being is I'm finding it's kind of hit and miss. Sometimes I'm having problems if I use this within version, well, the version that we're running on, which is 20.04. It seemed to be working okay when I was running it with 18.04, but this particular one, it seems to be a bit hit and miss. Sometimes the forward is not working, sometimes it's not. And what I'm finding is if I disable this, it tends to be a bit more reliable. So I'm going to save that file, and then what I'm going to do is I'm just going to do a quick check, because there's a command that I can run to check basically do like a parse that file and see if it's got any errors in it. So it is, right, it's this one here. So it's sudo named and then check conf. Right, so it hasn't come back with any errors, in which case that file does seem to be working okay. So in which case we've got our DNS actual forwarder configured. The next thing is to start looking into configuring the zones. Now, part of our plan is to have an actual DNS server that's responsible for our own local network, or at least this lab network that we've built. So we need a DNS server that we can use to resolve the host names, fully qualified domain names of computers on that network. And the first thing we need to do is to actually tell it what the zones are. So there's going to be forward zones and there's going to be reverse zones. A forward zone is where you're resolving the fully qualified domain name to the IP address. And a reverse zone is where you're resolving the IP address back to an actual host. I mean, that might be a case of, well, let's say a computer connects to a server and the server needs to do some check against the client that's connected to it. I mean, if it just sees an IP address, for example, it might say, well, I want to check who that IP address belongs to so I can, do a security check against it. And it'll then do a reverse lookup on the IP address to work out what the actual host name is, if you will. So if we just have a look in the folder, and we're in the /etc/bind, we've got some files, already in place that came as part of the service, but the one we're interested in is the named.conf local file, because that's where we're going to actually tell it about the zones, because each of the zones, there's a configuration file for all the zones we set up, but we've actually got to tell the system where the actual files are, what they're for, and so on. So I'm just going to make a backup of this file first. Spell. Okay, we'll just put our password in there. Oh, yep. I forgot to put the copy command in. Yep, it's not going to do much without an actual command. Right, so tell it to copy there. So we've now got a backup file for that. So, I mean, use whatever, text editor you want to use to copy this, but let's paste that name again. Okay, fat finger on the keyboard as ever. Right, so there's not a great deal in here to give you any clues, but what we need to do is to actually define what our zones are. So type in zone, and then we've got to tell it what the zone's called. So in this case, our zone's called templab.lan. So effectively, that's the actual domain name, really. So we're starting the definition, if you will. Now, this one's going to be of type master. And then we've got to tell it where the actual file is. So this is going to be stored in that same file folder. It's bind, not bin. And then we're going to call it, well, What you call the file doesn't really matter, but it helps make things a bit easier if you've got some like something to reference it by. You want to be able to spot it pretty easily, don't understand what it is. So I'm calling this one DB because it's the database, templab.land because that's the name of the domain. And that defines what is our forward lookup zone. So the zone's called templab.lan, type master, and we're telling it that the file, the actual configuration file for this zone is going to be stored at /etc/bind, and then the file itself is .db.templab.lan. And then I've got to do an equivalent except for reverse lookups. Now, this is a bit weird in the name and format. I actually remember it, oddly enough. I mean, I was doing my Microsoft certifications decades ago, and I still remember the format to this date. But it's basically you take the network IP address and you put it in reverse, basically. So in our case, I'm going to define one for what is the 172.16.17 network. So 172.16.17. So it's those three octets in reverse. The subnet is 172.16.17.0. So we don't put the 0 in. We just need those three octets. And then I'm going to put this wonderful little entry in. That goes back to our original ARPA network, the early internet. Right, so again, type master. So nothing much different there in terms of the format of the zone. Pretty much the same. The only thing I'm going to do different is when it comes to naming the file, I'm going to do it in a format that's easier for me to recognize. So 172.16.17. So instead of referencing the actual subnet in reverse, it's easier for me to look at that and know I'm dealing with a file that's specifically for that network. So I'm just going to double check my proofing here on the off chance I've got it right. What we'll see is we'll check it. So we'll save that. I'll just double check what the command is, because there's a command we can use to confirm that's working. So no, I can't yet. I've actually got to define the configuration files first. I was wanting to check the actual zone file itself, but I'll need to check the zone file against the configuration files. So that's what we've got to do next. So we've actually defined what our zones are, but now we actually have to configure the actual configuration files for each of the zones. So we need one file that's going to be for a forward lookup zone for our domain. So fortunately we do get existing files. So what I can do is I can reference this one here, for example, db.local, and I can use that just to save myself a bit of time. So I'm just going to copy that one, db.local, and I'm going to copy that to, now I've got to name this what I referenced in the actual zone file itself. So fortunately that is just the domain name, so it's db.templab.lan. So tell it to copy to there, and then use whatever text editor you prefer so that you can edit this actual file. And what we're going to do is we're going to make some changes to this so it suits our own purposes. So first up, I'm just going to change this to something more meaningful. It's just a description, so it doesn't really matter that much. But let's see. So it's for the templab.lan zone. Things like the timing that we got down here, all these different timers like TTL up here and so on, I'm just going to leave them on the default. So you can change them to whatever you like. I mean, these are all referenced in seconds if you like. I mean, you can change them into a different format, into hourly formats, for example. It's entirely up to you. But one thing I want to do is I need to change this entry here first. So this is going to be templab. No, it's actually, this is the name. So I've got to reference the actual server itself. So it's ns1.templab.lan. So this is what we refer to as the start of authority. This is basically the server that knows all there is to know about this particular domain name or zone. And if you note, it's always got to end as a dot. Now this entry here, it's a bit deceptive, I must admit. It's actually an email address. So we'll put in admin dot templab.lan. So it's not admin at templab.lan as you might think. It's in this format, it's admin.templab.lan. But again, it's an email. It would be something to reference for an email address. So if somebody was making queries against this DNS server and had issues, they want to know who can contact, for example, if there's a problem. So down here, serial number. We want to increment that serial number. I mean, technically, we're just starting from scratch. It doesn't really matter. There's only one server, but out of good practice, we want to increment that by 3, just so that we're making sure that the database is actually being kept up to date. Every time you make a change, you increment that serial number by 1. These entries here, I'm going to delete that one. That one there is an IPv6 entry, which we do not want. So here, we've got a reference to localhost. So the NS record refers to the name server. So that's a DNS server that you can go and talk to. So it's the same as the one up there, which is templab.lan. So it's at, yeah, we've got the at there. At's just basically a shortcut for the domain or the zone, if you will. So that's what I need to change for the A record. Now back here, what I'm going to do is I'm going to start putting in, these are going to be our actual host entries. So basically what we've done here is we've provided information of anybody who does any interrogation to say that ns1 templab.lan is basically the start of authority for this particular zone. That's who you can get in touch with to find out more information and so on. Down here we've defined our name server. So this is the name server that does the actual DNS lookup. So if you want to go and interrogate a DNS server to find out, say what's the mail server, for example, on templab.lan, this is the server you need to actually go and talk to. I mean, you would add more than one if you had more than one DNS server, and as a good practice, you should have 2 anyway, at the least, because you want redundancy. But it's for us as it's a lab, so it doesn't really matter. Now, what I'm going to do here is I need to be able to resolve that name ns1 to an actual host, to an IP address. So that's why I'm putting ns1 at the start there. And I'm going to actually put in the IP address of the server itself, which is 172.16.17.10. And we've got another server. It's another A record. So an A record is basically a host record for IPv4. And this one's going to be 172.16.17.12. I'm actually going to reference our firewall in here. Now, it does belong to the zone. It isn't going to be part of the reverse lookup zone we create. I'd have to create a separate one for that, but it doesn't really matter that these are in different networks. So this one's going to be 18.254. The reason I'm doing that is that's so that the management computer we've got can actually reference, FW1, well, actually just FW. It can reference fw.templab.lan, and when it does, it'll resolve to the IP address that it knows of to connect to the firewall with. Anything else that tries to connect can't get access to it anyway, so it doesn't really matter. So it doesn't really matter that it's in a different subnet, because this is just for the forward lookup stuff. So let's just double check that I've got everything covered there. So .10, .12. Right, so we'll leave that. Right. So that's that. So basically we've just got 3 host entries. Now I've got to manually put those in. Now let's just do a quick check. Let's see if we can get that compared. So if we do sudo, so it's named check zone. So the zone is templab.lan, and the file we're referencing is templab.lan. So there you go. So it's come back and it said it's okay, it's fine. So it's loaded. Serial number is version number 3. So that's the version, if you will, of the database. It's come back without any errors, so great. So the next thing to do is to create what's called a reverse lookup zone. Now the next thing we want to do is to create an actual reverse lookup zone. So that's where we are, we're going to have a lookup against an IP address and we want it resolved to a host name effectively. So what we can do is we can actually take a copy of one of the existing files. So like db.127, for example. So I'm just going to highlight that, copy that. I'm going to tell the computer to copy this, and we'll give it the name of the file as we defined it in the actual zone file. So 172.16.17. So that's what we've told the system effectively to go looking for. So we've copied that. It's pretty much just the same as the other forward lookup zone. It's just got pointers basically instead of A records, for example. So we'll copy that. You may use whatever text editor you prefer, but we'll just change the description. Oops. We'll change the description there. So instead of being for local loopbacks, it's for the temp lab LAN zone. TTLs, timers, not really fussed. So again, we've got to define the start of authority. So that doesn't really change. So it's temp lab.lan, and it ends in a dot. Define an email address that people can reference. So that'll be templab.lan again. So ns1 templab.lan and admin.templab.lan. We'll increment that serial number though. Ignore these other timers down there. We've got to tell it what the named server is, or give it at least one DNS server that computers can use to do their lookups. So that's templab.lan. And then here we actually start defining our pointers. So 10, for example, it's the the host IP address for ns1.templab.lan. 12 is going to be for the DHCP server, but that doesn't exist yet. I haven't got around to building that yet. Templab.lan, and I think I've covered all the ones I need for now, because I couldn't put the IP address of the firewall in here because it's a different subnet. Wouldn't apply. Okay, so I'll just save that. So just check that. So that's okay. So yep, define the start authority. Right. Okay. So we'll do a check. So sudo named. I think it's check. I think it was check zone. And then we want to put the reverse lookup literally in reverse. It's a bit weird. So it's 17.16.172.in-addr. Check that. It's easy to get it the wrong way around. So yes, it's sudo named check zone 117.16.172.in-addr.arpa, and then the actual file that we've defined, 172.16.17. So we're checking the zone effectively against our database file to see if it's suitable. So it's saying, yeah, serial number is 2, and that looks okay. So we've now got our forwarding set up. We've got our forward lookup configured, our reverse lookup configured. So there's a few more things just to complete, and then we can actually start testing the DNS server to make sure it all works. Now, before we actually start the DNS server, I want to make a change to the computer, because when we installed it, I had it pointing to an Internet DNS server, so that way I could get out to the internet, apply updates and so on. But I now want to change this so it points to itself. So I think it was around about version 18 that Ubuntu changed how you configure IP addressing within the system. So I'm going to change over to the Netplan folder because that's where it now exists. So if we do an ls, that's the config file, at least for this particular server. It'll vary. You go on different versions of Ubuntu and so on, and you get like a different file each time. Like on this particular computer, which is running Linux Mint, which is a version of Ubuntu, it doesn't reference the file like that. It's slightly different, but either way, I need to edit that file. So what I need to do is I want to point it to itself. So I'm just going to copy that file. Nope, I didn't want to copy it as an HTML file. All right, so copy that, paste that. Right, so that's what I want to change is the name server, because I want it to point to itself. Because basically this is a computer and it's running a DNS service. But I want the computer itself, if you will, to talk to its own DNS service when it's doing lookups and so on. So one thing I do need to do then is apply that change, because we've changed the configuration file, but the changes haven't taken effect until you actually run that apply command. So we've now got everything set up where we've set up our DNS forwarder, we've set up our two zones. We've got a forward lookup zone, we've got a reverse lookup zone, and now this computer is going to be pointing back to its own DNS service. So the next thing to do is to actually start the DNS service. Okay, then, so the next thing we're going to do is actually start this DNS service. So that's going to turn it into an actual DNS server that'll do its own internal network DNS lookups, as well as a DNS forwarder for access to public IPs, basically. So in our particular case, we need to use the systemctl process. So system, if I could spell, it would help. So sudo systemctl start bind 9. There you go. That was pretty quick. So we'll then go and check the actual status and see what we get back. The main thing I'm interested in is, yeah, it says it's active and it's running. Now, what I found is if I don't disable that DNSSEC option, I end up with quite a lot of errors, but I also end up with this like intermittent hit and miss problem with DNS forwarding. As I said, I don't actually have issues when I'm doing it with 1804. At least I don't think I did. But yeah, it just seems a bit strange. Now you can actually configure it, but in my case, I'm just disabling it. I'm just going to treat this as your, old-fashioned DNS server using UDP port 53 without the benefits of the security at this stage. So one of the first things I want to do is actually test it on this computer to find out if we can resolve anything internally. So if I ask it for template.man, so that's the DHCP server. It says its IP is 172.16.17.12. What about the name server then? That's 17.10. What about the firewall? So that's coming back as 172.16.18.254. So that's okay. So internally it seems fine, or at least on the actual server itself. Now, what about if we try to get to the internet? What's the DNS forwarding like? So www.amazon.com. There you go. So it's resolved the IP address. It can't actually reach it because I'm actually blocking echo, packets from going out anyway. So at least I know it's resolving that. So the question then is, what about this computer, for example? Can this actually get to anything on the internet now? So I'm just going to open up Firefox here. So it pops up, it's Linux Mint that we're running on this computer, and it actually pops up by default with the web page for Linux Mint. Now, if I actually click on that, okay, well that looks to be working. It's a bunch of things it's coming up with at the moment. Now, I haven't been to that site, for example, so will it resolve that? Yep, so we're getting to that web page. What if we pick another one, say, oh, the Irish Times. Let's see what we can get from the Irish Times. Yep, so it's obviously doing, resolution in terms of getting to the internet. So the forwarding does seem to be working. What if we try to get to our pfSense server? So if I type in FW, so you can see, been here, done this before, because I actually, before I tested it with version 18, but since at the time 18 was the preferred version, but now that 20 is out, I'm testing it with that instead. That's what this video covers. So you can see I've got that as fw.templab.lan, but type in that, so templab.lan, and port is, well, there you go, it's filled it in. Yeah, so it's logged in, or rather it's resolved, the actual internal host name and so on. So that's all working fine. We're getting out to the internet. Just for giggles, we'll just try a new window and try and see what we get from this computer. So what if we do 172.16.17.12? What do we get with the reverse lookup? Okay, so it's coming back and saying it's got a pointer to dhcp1.templab.lan. So yeah, it seems to be working fine. So ns1.templab.lan. Yeah, does seem to be working fine. So it's a case of we've had to do quite a bit of configuration. We're setting it up as an actual DNS forwarder. So if I just go back to my diagram here, we've got this DNS server acting as a DNS forwarder. It's caching DNS requests, but if anything comes to this computer asking for an IP address, or rather resolve a fully qualified domain name that's out on the internet, this server will actually go out and talk to one of those two Cloudflare servers, and they're providing sort of like malware protection for us. And where if they know of any particular website that we're trying to get to that's got malware, it just won't let us get access to it because it won't give us the actual genuine IP address that server's running on. But it's also a case that this server's, it's kind of like there's two layers to it. This is a DNS forwarder for all the computers on the network, and it's actually talking to DNS forwarders out over at Cloudflare. So the process of this server talking to these servers is speeded up because they'll be doing their own caching. The process of these computers talking to this computer, that'll be speeded up because that'll be doing caching of its own as well. So we're speeding up the whole DNS resolution process, which is good. But we've also got this added benefit of protecting us from malware. I mean, not every malware that's out there, just known infected sites basically, or ones that Cloudflare know of. If there's any computer on this network tries to get access to a public DNS server or any DNS server on this network, or at least one that's in a different subnet, the firewall's going to block it. The way I've got it set up is that computers that are on different subnets, they can talk to this server on DNS, but that's it. They can't talk to anything else. They can't go out to the internet. So if, for instance, this computer, say it got infected with some botnet and it needed to resolve some name on the internet, well, its only option is to go to that name server, which is then going to go out to Cloudflare. Whoever puts this software on the computer, they can reconfigure the computer, potentially point it to a different DNS server, but it won't work. The DNS resolution's limited to that specific server, so they can't get around that DNS option basically, at least not that way anyway, because they just literally can't get through the firewall to go to a different DNS server other than this one. So that's a bit of a benefit I do like as well. And it's also a case of, because I've got this firewall allowing access from this DNS server to the internet, if I make any changes, say somebody else comes up with some better DNS servers than Cloudflare, for instance, all I've got to do is make a change on this server here to point it to those, make a change on the firewall to allow access to those, because I'm being very specific. I'm not allowing this server access to the entire public internet for DNS resolution. It is limited to just either Cloudflare at the moment or Google, but it's a case of I just need to update 2 points. I don't have to go to anywhere else. The DHCP server is only ever going to give out this IP address of this server for DNS resolution. I mean, now granted, if you want to do like proper redundancy, you would set up a secondary server as well, and that would be feeding off that server, which is the master server basically. But in my case, it's just a lab, so I only need the one. But the good thing is now that we've got that up and running, I'll be able to get access to the internet from all points basically on the network. We'll just go back to our server here. So I'm back on this server, so if I do a sudo apt update, this computer can now get out to the internet, and it can, it can access the repositories, update the packages and so on. We can update it. Because I've been doing this before with version 18, I've been able to get open VM tools on it, which means I can now resize my console, and it adapts to it, which is good. Makes my life a lot easier doing that, I must admit. So yeah, it's quite a bit of things to do, but ultimately it's a case of we now got ourselves a DNS server, and that's how you do it. There is better options out there in terms of being able to get all the way up to like DNSSEC, for example, because that's a more secure process of being able to check who you're actually connecting to, making sure that there's no like DNS hijacking going on and all that sort of stuff. But in our case, I'm not too fussed at this stage because I'm just going out to Cloudflare, and I'm getting some benefit out of that, but I would really like to be able to get up to using DNSSEC. So that's something I need to think about. But at this stage, at least we've got a DNS resolution. Well, thanks for making it to the end of this video. I really do hope you found it useful. If so, then do click the like button and share, because that encourages YouTube's algorithm to suggest it to other people who might find it useful as well. If you're new to the channel and you'd like to see more content like this, then yeah, do subscribe. Just remember to click the little bell icon though, that way you'll get notifications when I send new content out. If you've got any comments, any suggestions, if you want to leave any feedback at all, please post that in the comments section below. And if you'd like to support the channel, I've left links to both Patreon and PayPal in the description below. But above all, thanks very much for watching. I'll see you in the next video.